My favorite thing about land speed racing is its simplicity. Just go as fast as you can in one direction. That direction is very specific though, because they have the starting line and timing lights all lined up, so you kind of have to go in that direction. Here's the problem. Speed is the rate of change in distance, but velocity is the speed of an object in a specific direction. Speed is a scalar, but velocity is a vector, so the way they have the course set up, it's technically not land speed racing, but land velocity racing. Also, escape velocity, which is just how fast you need to be going to escape Earth's gravity, is not a velocity, it's a speed. It doesn't matter which direction you go in, only that you reach that speed. It should be called escape speed. I have brought up my grammatical concerns with both the land speed racing governing bodies and NASA, but weirdly, I have not heard back yet. Anyway, this whole velocity vector thing means that I need to have steering so I can go in the prescribed direction. It's mostly straight, so I don't need a ton of steering, hardly any at all actually, but it does need to be there. And it does need to be consistent and predictable, so of course I have over-engineered a steering system that will solve my problems using only 7 ball joint turnbuckles, 2 pivoting links, 2 latches, 2 spindles, 4 bump stops, 1 U-joint, 7 bushings, 2 bearings, and a handlebar. Because why overcomplicate things? If you remember from before, my front suspension is a swing arm sticking forward. This is not a common suspension design, but it's not unheard of. The Citroën 2CV has forward pivoting swing arms, and they were impossible to roll over unless you were driving backwards. Anyway, some people had concerns that this would lead to the steering wanting to flop over to one side or the other, but that's not a concern. The suspension axis is behind the wheels, but the steering axis lands in front of the wheels. The steering axis is through the spindle pivot. If you draw a line through that pivot to the ground, you can see that it lands in front of the tire contact patch. This is really easy to see on a motorcycle. The distance from the tire contact patch to where that line intersects the ground is called your mechanical trail. The more mechanical trail you have, the more your wheels want to snap back to center like a shopping cart wheel. I didn't put a whole lot of mechanical trail into my front suspension, and after looking at some other land speed racing cars, I decided to add some more. My worry is that I won't have enough feedback in the handlebars, and it will be challenging to keep the car in a straight line. Some of the other cars had more than 15 degrees of caster, but I aimed for around 10. I could have just welded up a new front swing arm, but I decided to try and modify the one I have. I bolted it down into a mill and milled a slot in the top that was a consistent width. Then I just kind of hacksawed down the sides to make a V-groove, that way I could bend it back a consistent amount. I did that, welded the tops and sides, and reassembled everything to make sure I still had the same heights and angles on both sides. It all worked out, but unfortunately I had to paint over the weld, so I don't have a gold-colored front swing arm anymore. Only the rear, which did get a clear coat to help protect it. So the wheels pivot around these spindle mounts on the front swing arm, but how do I control them? Typically you'd have a steering rack with a couple of spherical jointed push rods connecting the rack to the spindles. This is how my Jag works. This is how my Honda works. It's how almost all cars these days work. The problem with this design is that steering racks are typically wider than my entire car. If I had independent front suspension, the control arms would be about 3 inches long and the steering rack would need to be infinitesimally small. With the swing arm front suspension, I could probably modify an existing rack to fit, but I'd have mad bump steer as the tires moved up and down unless I mounted the rack to the swing arm. This could be done, although I'd need to solve the problem of the suspension moving up and down. There are 2 ways to do this. One is to use a telescoping steering shaft. A lot of steering shafts are designed to telescope when you adjust your steering wheel position, but they're not really made to be consistently moving in and out with the suspension travel. There are linear bearings that can do this, so I could probably make this happen. The other way to fix this problem is to have a U-joint right at the pivot axis. You can imagine a steering shaft coming in here, a U-joint in the middle here, and then the output going to a rack mounted to the swing arm. This is kind of what I did. Kind of. You see, I actually want handlebar steering like a motorcycle. I want this because the cockpit is really tight and the handlebars allow me to have all my controls right at my hands. Throttle, clutch, brake, gear shifting using buttons. This will make the cockpit less messy, it will put all my controls where they are easy to reach, and it's safer. When race cars crash, your arms tend to flail around uncontrollably. If they get outside of the vehicle, then the salt flats turn pink with the ground up paste of what used to be your arms. To prevent this, you wear arm restraints. The arm restraints only work if your arms are restrained from going outside of the vehicle, and outside of my vehicle is about 6 inches from where my arms normally are, so I need super short arm restraints, which means I need all my controls to be right here. My original design used push-pull cables from the handlebar to the spindles. This is a great idea because the cables can flex with the suspension and you can run one to each wheel and also connect the wheels together so you have a redundant system. Unfortunately, this is not allowed by the rules. I'm not super surprised at this because this is one of those things that could be done well but could also be done very poorly. You can get push-pull cables that are rated for the appropriate strength and stiffness, but you can also cobble something together with crap you found from the junkyard, and sometimes it's hard for the tech inspectors to know if you did it right or not, so no cables. I'm using links, 7 of them, 8 if you count the handlebars. Here's the basic idea. You rotate the handlebars like you would on a bike. That pushes this rod and pulls on this one. That rotates this shaft here clockwise. On the bottom of this shaft there are 2 more push rods, one going to the left wheel and one to the right. The one going to the left wheel pushes forward on this little tab I have bolted to the bottom of the spindle. That turns the wheel to the right. The other push rod pulls on the right side wheel, causing it to turn to the right. The spindles are also connected together with another push rod in the front. To make this work with the suspension, I added a U-joint in the vertical shaft right at the swing arm pivot. So as the swing arm pivots up and down, the U-joint will bend slightly, but it won't change the steering. U-joints do have a varying velocity as you increase their angles, but this joint will never be more than about 4 degrees, so it shouldn't be noticeable in the steering. Total steering is also only 8 degrees. This doesn't seem like hardly any at all, but it's more than some of the streamliners out there. The limited steering is really driven by aerodynamics. The vehicle body has to cover the wheels at any steering angle, so the more steering you have, the larger the frontal area is, and the slower you go. Some of you are wondering if I couldn't have a flexible body that moves with the steering. This sounds really complicated, and you know my saying, keep it simple, stupid. Unless the complicated solution sounds like it would be fun to design, then do that. But otherwise, keep it simple. Here's the cool thing about this design. It's all redundant. I could take out any one of these links and the car would steer both wheels just fine. So I don't have to really worry about the strength of a single joint or buckling or the stiffness of these individual bars. Pretty cool. But I know I have some engineers who watch my videos, and I know engineers like nothing better than to point out when somebody else is wrong. So I know several of you are already halfway through a comment telling me that this won't work. Why? Because with this geometry, as this part here rotates, these 2 spindles rotate at different rates. So this front link wants to get a little bit longer. If you run the kinematic analysis on a computer or on paper, it doesn't move. It has 0 degrees of freedom, theoretically. But as Yogi Berra once said, in theory and practice are the same. In practice, they're not. And in practice, this linkage works just fine, at least for the 8 degrees of total steering that I'm using. In that range, this front link wants to lengthen by about 1/10,000th of an inch every time I turn the wheel. That's about 2.5 microns. In theory, it can't do that, but in reality, none of this stuff is as infinitely rigid as we'd like it to be, so a couple of microns is no sweat. If you turn the steering more than about 15 degrees, you can kind of start to feel it binding, but it's not even noticeable in the middle, and that's way more than I'll ever be steering anyway. This is also true to a lesser extent with this part up here. I have these holes in this part to adjust the ratio, but these push rods need to be parallel or this part of the system will theoretically bind, but it seems like the effect is so small that it isn't even noticeable. The other cool thing about this design is that it easily flips up out of the way so that I can actually get into and out of the car, which is nice. Remember those push rods attached to the handlebars? They actually go to an intermediate pivot. This does 2 things. It limits the length of these push rods, which eliminates any worry about buckling or wobbling. They also allow the whole steering assembly to pivot up. The pivot axis lines up with the handlebar assembly axis. This is only true when the steering is straightforward, but it does work with the wheels turned slightly. It just rotates the handlebars a bit. To get this all assembled accurately, I welded the pivot tabs and then ran a bolt through to hold the short rotating links in the same axis. Then I welded the tabs to the frame that hold those short links. To latch this whole thing down, I use these over-center latches on the back of the crossbar. These go through these welded tabs on the crossbar and into these tabs welded to the frame. So for this to fail, it would have to shear this pin, which would require a lot of force. I want this to be secure because this is part of my leg restraints. Remember before how I was talking about arms flailing around in a wreck and turning into a pink paste on the salt? Well, that can happen with your legs too. The frame closeout panels constrain my legs to the side and bottom, but I need something on the top that can retain my legs but is also movable so I can get in and out. This will be augmented with a net or maybe just some sheet metal plates attached to the pivoting assembly. I don't know, I haven't gotten that far yet. I'll probably also add a gas strut to this part so it doesn't come crashing down on me. I'm not entirely sure this will feel intuitive to steer. I do ride motorcycles quite a bit, so I'm used to the controls, but motorcycle steering has a feel to it that comes from the fact that you lean. If you want to go left, you kind of just push left on the handlebar, counter steer away from the turn, and then lean into it. This car doesn't lean, or at least it's not supposed to, so it may feel a little odd. If I push on the left side handlebar, it won't countersteer and lean to the left, it'll just steer to the right. I'm not too worried about this, it may just take some getting used to. Trikes and sidecar motorcycles all steer the same way this thing will steer, so it's probably pretty straightforward. The other thing that might be a concern is the steering ratio. It's dialed down right now, so when I turn the handlebars 5 degrees, the wheels only turn 3 degrees. This still might be too much. The car is designed to go a couple hundred miles per hour, and at that speed you need very little steering input. I've been told that most of the people who build streamliners end up increasing their steering ratio. I could do this pretty easily. I can move these two rod end mounts on the handlebars in toward the pivots. I could also modify this mount to move them way in if I need to, but we'll do a shakedown run the way it is and see how it goes. This steering ended up taking way longer than I thought it would, mostly because there are so many parts that need to be made and purchased for it. I kept buying stuff and assembling it together only to realize I needed a slightly longer bolt or a shorter nut or a different part entirely, but I did get it together. We set up the toe in at 0 degrees, which seems like a good place to start. We also put the wheels on and checked the corner weights. This is it with me in it, not bad, a little rear heavy, but the car will have a tail sticking way out the back, so it should still be aerodynamically stable. Pretty cool to see it with the wheels on. It is a real rolling chassis, and it steers. Soon it will also go vroom vroom. So I went out to the first El Mirage race of the season, but I didn't bring the car. I was going to run it through tech inspection, but it's not quite ready for tech inspection, and it's definitely not going to be running for the next event. So I'm going to finish it up a little bit with the goal of having it ready to pass tech at the next event next month. I did get my car number though, and I know what you're thinking. I chose 420 or 69 or 5318008, which spells boobies upside down, but no, that's not what I chose. I chose
1, 2, 3, 4.
They only let you choose 4 digits, so that's it. 1, 2, 3, 4.
That's the kind of thing an idiot would have on his luggage!
Now I just need to get sponsored by Five Guys or Five Gum or Big Five Sporting Goods. Anyway, that's it for this week. Tune in next time. Same Matt time, same Matt channel. Probably a different Matt time, actually. I'm not very consistent with these things, but same Matt channel. Not this Matt channel. Not this Matt channel. This Matt channel. At some Matt time in the future. It used to be that you had to impress people to get people to watch your show. Now you just have to impress the algorithm. So do me a favor, hit that subscribe button. All hail the algorithm.